Given question, a ladder is placed against a vertical wall as shown in the diagram. The coefficient friction between the wall and ladder is 0.19 and that between floor and ladder is 0.3. In addition to self-weight, the ladder has to support a man weighing 599 Newton at a distance of 3 meters from A. Calculate the minimum horizontal force to be applied at A to prevent slipping.
Let us understand given question with the help of diagram. Ladder AB of 4 meter length is given. Point B is in contact with vertical wall and point A is in contact with horizontal floor. Ladder is inclined at an angle 60 degree. Weight of ladder 199 Newton passing through point G in vertically downward direction. Inclined length A to G is given 2 meter. Man weighing 599 Newton is given at point C, where this weight will act in vertically downward direction passing through the point C. Inclined distance from point A to C is given 3 meter. Now we have to find out the horizontal force applied at A to prevent the ladder from slipping. So we have to first show the motion of this ladder at point B as well as at point A. Now the point B is in contact with vertical wall. So due to the gravitational force, this ladder will tend to move in the downward direction. So we will show the motion at point B of the ladder is in the downward direction. As this point B will move in the downward direction, the motion of ladder at point A is towards the left hand side along the horizontal floor. So we will show here the motion of ladder at point A. So this is the motion and we have to prevent this ladder from slipping. That means we have to show the equilibrium of the ladder. So for that we will consider the equilibrium of the ladder and we will draw the free body diagram. So the inclined distance for this length AB is 4 meter and we have to show the angle of inclination is 60 degree with horizontal line. So we will show here the angle is 60 degree. Now the man weighing 599 Newton we have to show here at point C in vertically downward direction and weight of ladder at point G 199 Newton in vertically downward direction. Now the motion of ladder at point B is given in the downward direction. So frictional force will act in the opposite direction. So we will show here the frictional force that is it is at point B. So we will show here as a FB in the upward direction. So this is the frictional force FB. Now normal reaction we have to show perpendicular to the surface. Now surface is vertical surface. So we have to show normal reaction, that is the horizontal line, and that is known as NB. Now at point A the ladder is in contact with floor. Now at point A ladder movement is towards the left hand side. So frictional force will be in the opposite direction. So we have to show this frictional force, that is Fa. And normal reaction will be perpendicular to the surface, that is the vertical line because surface is horizontal, and that is Na. We have to find out applied force P which is acting at point A to prevent the ladder from slipping. So we have to show the force P which is acting towards the point A in horizontal direction and we have to show P is equal to question mark. Now we will consider the moment of all forces about the point A is equal to 0. Now why to consider the moment of all forces about the point A only? Now if we observe the unknown forces, then at point B there are two unknown forces, FB as well as NB. And at point A there are three unknown forces, NA, then FA as well as P. So if we consider the moment of all forces about point A is equal to 0, then the forces which are acting at point A will become 0. Now it is easy to find us this FB as well as NB. Now there is one relation in between FB and NB. So this ratio FB divided by NB is equal to coefficient of friction mu. And it is mentioned in the question, it is equal to 0.19. So we can use this relation, and if we find any one force FB or NB, then we can calculate the other. So we will first take the moment of all forces about point A is equal to 0. So how to take this moment? So we know that force multiplied by perpendicular distance. And we have to check whether this motion is in clockwise or anti-clockwise direction. Now we will first take NB. Now this force NB, if we observe, it is towards the left hand side. Now if I extend this, then this force multiplied by the perpendicular distance from point A. So if I draw here one vertical line, so this is the construction line. And if I extend this line passing through point A, then here is one point I will get. We will say here that this point will be X, and this is the perpendicular, that is 90-degree angle in between these two lines. So this force multiplied by perpendicular distance. So how to find out this perpendicular distance? So in triangle AXB, here is 60-degree angle and distance AB is known, that is equal to 4 meter, and that is mentioned in the question. So what is its value? So it is opposite to angle 60 degree, so we can say that it is 4 sine of 60. So we will use here NB into 4 sine of 60. Now if I move the compass in the direction of this NB about point A, then here is the motion in this anti-clockwise direction. Now for this anti-clockwise direction we will use the positive sign. So plus NB 4 sine of 60. Now we will take the next force FB. Now for FB also we have to take here the perpendicular distance. Now if I draw one line passing through point B, then from point A what is the perpendicular distance? So in between this line, vertical line, and this horizontal line, because it is in the vertical direction, so this horizontal line is the perpendicular distance. So here the angle is 90 degree. So A to X distance. Now it is nearby to 60 degree and length AB is known. So we can say that 4 cos of 60, because it is nearby to length. So AX is equal to 4 cos of 60 multiplied by FB. Now if I move the compass in the direction of FB, then it is also in anti-clockwise direction, because we have to move the compass in the upward direction. FB is in the upward direction. So we have to use plus FB 4 cos of 60. Now we will take this weight. So if we observe, we have to, again it is in the downward direction. Now if I draw one construction line passing through point C, then here is the point of intersection, and this point of intersection we will say Y. Now what is the perpendicular distance? So here is the point A and here is the point C. I have extended this up to Y. So it is in the vertically downward direction. So perpendicular distance is A to Y. So how to find out this distance A to Y? Because distance A to C is known. It is 3 meter. So 3 cos of 60. So we have to take 599 into 3 cos of 60. Now if I move the compass in the direction of 599, then it is in the clockwise direction. So for clockwise direction we have to use negative, that is the opposite sign. So we can use any sign, but for opposite direction we have to take opposite sign. So we will take minus 599 into 3 cos of 60. Then we will move for this 199. So again I will draw one construction line passing through point G, and if I say Z, then minus 199 into this A to Z distance, that is 2 cos of 60. So again we have to take 2 cos of 60. Now these all forces about point A is equal to 0. So no need to mention this, and which is equal to 0. Now if we observe here only two unknown force FB as well as NB. Now if we solve this, then we will get, we have to simplify this. We have to calculate these known terms, that is the constant terms, and we have to calculate the coefficients of FB as well as NB, and then we have to minimize the value. So final solution 0.866 NB plus 0.5 FB is equal to 275. So this is the relation that we get in for these two unknown terms FB and NB. But FB by NB is equal to mu, that is 0.9. FB is equal to 0.19 NB. So we will replace this FB and we will take the NB as a common term. So 0.866 plus 0.5 into 0.19, bracket complete. So we have to solve this bracket first, then we will calculate NB. NB is equal to 284.6 Newton, and from this value of NB we can calculate FB, because here is the relation. So FB is equal to 56.9 Newton. So in this way we will get these two terms FB and NB, that is two unknown terms. Now we have to find out three terms, NA, FA and applied force P. So summation of all vertical forces is equal to 0. So we will consider the equilibrium of ladder, and at this time summation of all vertical forces is equal to 0. Summation of all horizontal forces is equal to 0. So summation of all vertical forces, that is NA is in upward direction, we will consider positive sign, plus NA minus 199 minus 599 and plus FB is equal to 0. So NA is equal to, because FB term is known, so NA 743 Newton, and from this NA we can calculate FA, because the relation in between FA and NA, that is FA by NA is equal to 0.3. So FA is equal to 0.3743, that is 222.9 Newton. Now we have to find out P. So summation of all horizontal forces is equal to 0. So here P towards right hand side, then FA, both are towards right hand side. So FA plus P minus NB. So when we put here, because FA is known, NB is also known, so P is equal to 61.7 Newton.